So welcome everybody to this webinar. My name is Monil Patel, the Global Product Manager for Quantabio. And I've got the privilege of introducing some wonderful individuals from Midwest Microbio who will share their own story, but have really worked to support brewers and really tackle important challenges in the brewing space. So both Frank Luther and Aris Klimas are two of the executive members of Midwest Microbio. And we'll take the next 30 minutes or so to share their story and highlight their work. But without further ado, please help me welcome Frank Luther and Aris Klimas.
Thanks, Monil. Hello, everyone. This is Frank Luther, one of the founders of Midwest Microbio. Let me click to the next slide here. And we are just going to go over some of our objectives today for this approximately 30-minute presentation with about 15 minutes reserved at the end for Q&A. So we just want to dive into, who Midwest Microbio is. We're going to introduce the leadership team of the company. We're going to briefly go over some qPCR basics and how it all works. Aris is going to dive into some of the expectations versus reality of kind of the state of PCR and qPCR as it relates to the brewing industry these days. We're going to dive into the details of our qPCR solution for the brewing industry. We'll talk about costs. With the pandemic, costs are always a concern with our clients and potential clients. And we're going to dive into what real-time data analysis looks like with our system. So we'll let Aris kind of talk about himself here for a few minutes. No, I'm kidding.
Hi, so my name is Aris Klimas. I'm the CTO at Midwest Microbio. I have a background in biophysics and biochemistry, and I've had 2 to 3 years prior to starting this company at Platform Brewing and Masthead Brewing as a laboratory technician.
And again, Frank Luther here, co-founder and CEO of both Midwest Microbio and Masthead Brewing Company. We'll talk about Mike, my business partner for both ventures here in a minute. But Mike and I founded Masthead Brewing just 4 years ago. So we had our 4-year anniversary this past January. So I've been doing that full time for about 5 years, with including the startup period. Prior to that, I was an engineer and project manager with Procter & Gamble at a few different places around the continental US. So all in all, about 10 years experience in brewing and manufacturing, again, with a focus in industrial and engineering. Mike Pellicciati, who rounds out our leadership team here at Midwest Microbio, he was actually my roommate at the College of Engineering at Ohio State. So Mike was an electrical engineer. After he graduated, got a position as a head brewer at a brewery up here in Cleveland, and has functioned as our head brewer at Masthead for about 2.5 years. Recently has given up that title, to focus on important things like paperwork and also this venture. So the three of us round out the leadership team here at Midwest Microbio. And I want to talk just a bit about, why we started this company. About 3 years ago, we bought a qPCR or a PCR system, that's tailor-made for the brewing industry. Some of our friends in the brewing industry had it. Aris actually used it at Platform Brewing as well before he made the move over to Masthead to kind of get our lab up in tip-top shape. So again, we were a pretty rapidly growing brewery at Masthead, and we've grown it to about 9,000 to 10,000 barrels a year. So we're definitely in the strike zone for a brewery that should have pretty decent sized lab with a lot of capability built in. So we got this system in-house and found some limitations pretty quickly once we got the system up and running, especially with all the different yeast pitches that we have coming in. We're running anywhere between 2 to 4 different strains of yeast at any given time through our cellar. We have yeast pitches hitting our dock at like 11 a.m. and getting pitched into wort at like 2 p.m. So we just had some challenges maintaining a clean brewery with just the complexity that was going on. And then also the limitations of the PCR system that, again, we had bought about 3 years ago.
So I had previously worked at Platform using PCR technology, and also Masthead had adopted the same platform. So, when I first started, I was real excited about it. It seemingly was an easy solution, and seemingly also accurate. But as the beer industry kind of evolved with new styles such as fruited kettle sours, triple dry hop New England IPAs, a lot of issues came up. And as a quality lab technician, it's never a nice spot to, have to call the owner at 7 a.m. when you just developed the $80 in results and it's saying everything's infected, yet your hunch from, traditional micro or plating, you believe that everything's clean. So there's a lot of headaches with, just having to overanalyze, rerun samples, 2 or 3 times, burning a ton of money volts, and ultimately going off of plating after spending all that time. Another thing was enrichment, where I would have to wait a couple hours for PCR to enrich and then run it. So that was a pretty big problem as well.
So all of the challenges and roadblocks that Otis just explained really kind of gave us the idea of, hey, I think we can do this better. It might take a lot of time and a lot of money to get it right, but I think there's the opportunity out there to bring a better solution that the industry really deserves. So here were some of the goals that we set out to achieve if we were going to actually develop this system. Because again, I think this is what the industry really needs from a qPCR system. As an industry, we need to be able to rapidly screen for all beer spoilers and also be able to quantify the risk of those spoilers if we do find them. For instance, highly diastatic and poorly diastatic yeast. In our research, the risk presented by those 2 different variants of diastaticus is something worth knowing for sure. And it needs to be sensitive. So we put ourselves kind of on the spot with the goal of 1 cell per milliliter without enrichment. I'll talk a little bit about enrichment and why I think it's really not a great fit for the brewing industry. Some of the other systems out there require a 48 to 72 hour enrichment that they claim allows you to grow up these beer spoilers into the detection threshold of their systems. Our research has shown that, especially for viable but not culturable beer spoilers, that actually all you're doing is diluting the sample that you do present to the enrichment broth and just further push the detection threshold down of the other systems out there. So again, just the time involved with enrichment and the fact that even 48 or 72 hours of enrichment is sometimes going to have no effect on the quantity of these organisms in the broth. Feedback on inhibition is important. There's a lot of different styles of beer out there with a lot of different adjuncts and ingredients, many of which are PCR inhibitors, which can stop the reaction dead in its tracks. So having a system that can actually tell you if you are experiencing inhibition in your reaction was essential. The main thing was that the industry needs a solution that's cost effective. It needs a solution that doesn't penalize you for testing. For instance, with the system that I bought at Masthead 3.5 years ago, we're spending over $80 per sample to screen for common beer spoilers. And then, if you wanted to run it in duplicate, or if you weren't sure that you trusted the results out of it, you're spending even more than that. And if you look around your lab or you look around your cellar, there's other QA type devices that you have in your toolbox, none of which charge you like on a per use basis. Like your dissolved oxygen meter doesn't charge you every time you use it. So that's just an analogy that we like to use to just kind of highlight the fact that, yeah, you shouldn't have to pay $80 every time you want to screen your beer for beer spoilers. And the other thing that kind of annoyed us as a company was other industries have solutions that kind of fit the bill with what I'm describing here. And for some reason, the brewing industry is kind of lagged behind with a custom built solution that meets some of the other performances of other industries. The one thing we also want to be able to do is log data. So I always believe that, you should be data-based, and with a QA lab, you should be able to archive and log your QA and QC activities. So with a laptop-based qPCR system, you can literally save your runs that you can pull up in the future in the event that the FDA decides to, put any more regulations on our industry. And again, just to reiterate about cost effectiveness, we set out to make a system that was very low cost per use. So after about 10,000 hours of validation, and that's not an exaggeration, we do have a system that we're offering to the brewing industry, specifically designed for the brewing industry by brewers. So our validated system offers the ability to screen for over 35 different beer spoilers and genes within those beer spoilers. So 35 separate assays that you could use to identify exactly what's in your beer. Pretty quick too. So start to finish, from taking a sample from a tank to finishing the qPCR cycles, it's about an hour and a half. And we hit our target of under $4 per sample to screen your beer for hop-resistant bacteria, Diastaticus gene, Brett, and general brewer's yeast. And that under $4 per sample includes all your consumables. So all the different tubes and pipette tips that are necessary to actually go through the workflow. And we did hit our goal of being able to detect 1 cell per milliliter in a sample without enrichment. And Otis on the next slide is going to dive into a bit of what are the details, what went on during the validation of our system.
Yeah, so as Frank mentioned, we put a lot of time, both with Quantabio and working with other breweries to be able to bring the solution to market. Alongside doing this with media and competing PCR solutions, we ended up having to come up with 14 different validated protocols so that if you have a triple dry hop New England IPA in a fermenter, you're able to process that, remove the hops without diluting down your sample. And also with some of these new styles with fruited kettle sours, you have inhibitors present in that will basically inhibit the PCR action. And from that, you have to have a specific protocol to be able to strip all of the fruit purees or coffee adjuncts out, and from there be left with just the cells. And if any of those inhibitors are moved downstream, you're able to remove them and have pure DNA that will be uninhibited. Another big focus was, there is research out there for primers that are specific for, brewer's yeast or Diastaticus, but they're not that sensitive and they're incredibly unstable. So from the ground up, we had to go and design custom primers that wouldn't fold in on themselves and also would be able to have the sensitivity of 1 cell per ml without, NTCs or sensitivities where the Diastaticus one also hits brewer's yeast. So we put in a lot of work so that the end user has a headache-free system without any issues.
And so I just wanted to throw this slide in there just to visually describe the difference in cost between running our system versus many of the other systems that are commercially available. So to run 500 samples, you're looking at about $570 in reactions and reagents for our system. And if you look at some of the other competitors that are out there, your ongoing costs of a subscription-based system really start to stack up. I know when we were using the previous system I invested in, we were spending upwards of like $30,000 a year for the subscription-based system. So again, with our system, you're not penalized for testing. You're not penalized for running everything in duplicate if you choose to. You're not penalized for screening your incoming yeast. You're not penalized for running your wort if you want to look for Megasphaera or any other wort spoilers that are out there. A lot of our clients will actually run their beer pre-dry hop just in case something happened in the fermenter and they don't feel like dumping $20,000 worth of dry hops into a contaminated beer. We have customers that do screening on every fill head of like their canning line or their bottling line in some frequency just to give them greater peace of mind. So again, this graph just kind of shows the difference and the advantage our system has on an ongoing cost basis.
Some of you might be familiar with qPCR from training, and some of you might not know anything about this technology, but have heard it just in passing. So to start from the ground up, essentially with any beer sample, you're going to have DNA present, most likely, and hopefully it's an example like this where it's just brewer's yeast. The great thing about PCR is where you have a few cells present. In those few cells, you have hundreds or thousands of copies of DNA that is targetable. And through PCR, you're able to take, say, 100 copies and double it in another cycle to 200, and then 400 and 800, and exponentially increase it. And from that small amount of copies, by the end of it, you have trillions of that same exact copy with these specific primers we develop. Using the Quantabio Cyber Green, that dye binds to the double-stranded DNA that you're replicating each cycle. And from that, you're getting this real-time data showing this sigmoidal curve.
So this is what you're hoping for when you run our system. So this is basically an example of the core four, the 4 different assays. And the only one that had any DNA template present that was amplified was, General SAC. Now this next slide, so this is an infected beer, a contaminated beer. This is actually one that we pulled off of the shelf at a local grocery store right down the street from our brewery. So here, you've got general yeast, you've got diastaticus present, pretty high amount there. And then you've also got hop-resistant lacto and pedio. So this is what you don't want to see if your goal is to make a clean beer. But again, it does happen, right?
Furthermore, not only once you've been able to confirm that all your beer is clean, we have some clients like Saucy Brewworks, also local here in Cleveland, that's my jam. It's a heavily fruited beer, and this one has a ton of inhibitors, and more than just inhibitors, it has unfermented sugars that you're adding into the beer cold side. So using our system, they can validate that the beer going into the bright tank with the fruit puree is clean. Post spinning through centrifugation, they'll strip out the cells, use our system to monitor it, make sure that the cells are below 10 cells per ml. And then from that, because the results are uninhibited, make sure that when they add the two together, the fruit puree and the centrifuged beer, it won't re-ferment, even though it's clean and you have unfermented sugars added to it. So with these protocols, it's been great for our clients to be able to open up new avenues and even validate their clean beers that they won't re-ferment.
Yeah, that was a cool project for us to work on. So with a particular yeast strain that they used to brew this beer, they've validated that if they can spin their beer down to less than 10 cells per milliliter post centrifugation, that they experience no re-fermentation at all. So now they actually use our system to make sure that their beer is in spec prior to fruiting it and packaging it.
As mentioned, on top of this, it's qPCR, so you get the quantification aspect of it. And since it's real time, as you're running your sample, you can know early on if you have a major issue, if the yeast pitch that needs to be pitched in the next 40 minutes is infected. You get all of that data up front, and by the end of it, you get a report that clearly shows what inhibitors are present. From our validation study, you'll get a window of how bad it is, and from there get quantification of risk assessment. Being able to say, this is a small amount, we need to increase our, CIP procedures, or, hey, something really bad happened here, this is going to have to go down the drain because we can't send this out on the shelves. So this is crucial data that our system provides in real time.
Yeah, just to add a little bit more to that, we have customers that'll reach out to us and say, hey, I got a hit at like 1 cell per milliliter of like hop-resistant bacteria. What should I do? And I'm not in the business of telling people, to dump beer or how to brew beer. But the research we've done, 1 cell per milliliter of like hop-resistant pedio is, for the most part, not gonna completely destroy your beer. So just the ability to have that resolution of data to really see a problem before it becomes huge. Like, for instance, I would advise the customer, yeah, you probably shouldn't repitch out of that fermenter if you know you have a low level infection. So at least they're cutting the head off the snake there. Most infections we see start a few generations prior, and a lot of them come from the repitching of yeast, and the concentration of those beer spoilers grows every time the yeast gets pitched from one tank to another.
Furthermore, with our system, we put in the IAC, the internal amplification control, and this is a really great tool that our system offers that no other one offers. This is a synthetic DNA for our core 4 that targets all the general beer spoilers, and we put it at the beginning. So if you have a sample and you follow a general protocol and the IAC doesn't hit the initial parameters of amplifying within the first 8 cycles, you'll see that, be able to work back one step to the DNA you prepared. From there, be able to prep it in a way that you remove the inhibitors. On top of that, you also can use this to make sure that you're properly manufacturing the master mix and that nothing you're doing is improperly done. And this gives a great level of confidence to the users that they know that their sample is not inhibited and they're properly manufacturing the master mix.
And again, yeah, this just goes back into the goal that we had of developing a system that gives the user feedback on whether everything is working or not, which was something that the system I invested in 3.5 years ago very much lacked.
We also, using the Quantabio Q and Quantabio support with the software, have a melt curve analysis, which no other system on the market offers. This is an exceptional tool where with the primers, you're forming a product. With this, you can see that exact product, and on a couple of our assays, you'll be able to identify if it's a highly or poorly diastatic strain, if the hop-resistant strain of bacteria you're detecting has, one gene or all 3 of the genes. And from that, it gives you a great benefit for the risk assessment that we were talking about, where you can say, hey, yeah, we have 100 cells per ml of highly diastatic yeast in this yeast pitch. That's going down the drain. Or also, if you do get NTCs or negative template controls in your reaction, you'll be able to see those because the melt temperature will be significantly lower, between 65 and 70, and that will give you confidence that your beer is actually clean. So this is an excellent tool. And also, if you have a false positive, say your stat amplifies, if it doesn't line up with either the poorly or the highly diastatic region, you'll be able to throw that result out. So once again, it's just another layer of confidence in the results.
So here's a cool slide that we like to throw in our demos and our presentations, just to kind of show all the different assays that we have and the power of them. So this is a sour beer from one of our customers. Count the different number of assays that are popped here. So it's a sour beer that had nearly every beer spoiler in it, which again was a really good beer. And this particular customer is known for their sour beers. What our customers that have wild ale programs really like about our system is that they can actually track their house culture from barrel to barrel. A lot of our clients have fooders, and that's really helped add another lens into their fooder to see what's really going on. Like, do they have hop resistant bacteria in their fooder? Do they have diastaticus? So for this particular customer, they found that after a year and a half or something in a fooder, that some of their house culture actually died and wasn't able to be revived when they put fresh beer on top of it. So they ended up figuring out that they had to repitch some of their bugs into this fooder every time that they refilled it. So again, it's just for the customers that are out there that really take pride in their sour programs. This just gives you another tool to learn more about your house culture. If you get a barrel from another brewery, for instance, and you really like what is coming out of it, again, you can actually quantify and see what beer spoilers are in it and how that microbiome of that barrel changes over time. So we just kind of want to summarize what we actually offer to our customers. We'll go in and give you all of the equipment you need to make your lab fully qPCR ready, and we'll give you about 300 reactions worth of consumables, so you don't have to worry about reordering any consumables until you're definitely up and running and very comfortable and proficient with running the system. And again, like we talked about on the previous slide, you get 35 different assays in your molecular toolbox that target different genes, microbes, and gives you species level ID of these beer spoilers. Our training and support and our startup plan consists of about two days on site or virtual. And during that, you get trained on the 14 different protocols to actually run the system, depending on what type of sample you're throwing at the system. At the end of that two days, we actually have a qualification program where we're checking off boxes as the trainees are, actually demonstrating proficiency in the different steps in the workflow. And then, so basically at the end of the two days, we have a document that shows that, all the trainees have demonstrated that proficiency, that you feel confident in the system, and that we feel confident in you and your team's ability to run the system on an ongoing basis. And then, of course, along with all the system, we do provide significant cost savings on an ongoing basis versus many of the other options that are available out there. So here are a few pictures of what the equipment actually looks like. So the orange Bluetooth speaker looking device there in the middle of the photo on the left is the Q provided by Quantabio. So that's a 48 well thermocycler. Pretty cool. It actually spins the sample as it's reading the fluorescence. What's really nice about it is it only has one set of the photo sensors in it, so there's no calibration die required to run the system on an ongoing basis. I mean, the Qs that we've had, and we've put how many cycles through them on us during validation, and
yeah, thousands, like both at the same time.
Use a pretty standard benchtop centrifuge, which is there on the right, that fits the 50 milliliter sample tubes that are also pictured there. We also provide like a medical grade lab freezer if your lab does not currently have one. We got a mini vortexer in there that's used in our sample prep. Yeah, I mean, it's what's nice about this system is that it doesn't take up much counter space at all. I mean, really the largest thing is the centrifuge and the fridge. I mean, the Q itself is what, a 7-inch cube, I think?
It's like 6 by 6, yeah.
Yeah, so it's super tiny. It doesn't, it's not as big as like a dishwasher, like some of the other qPCR equipment we've seen out there. The reason we went with the Q is just the cycle time and the flexibility, and the fact that you don't have to enter into like an annual service contract. Some of the other cyclers out there, you're paying upwards of 10% of the purchase price of the equipment every year. A, for the licensing, and B, to buy the calibration dies and get the thing serviced.
We kind of thought this would be a good talking point, just because when we talk with potential clients or people that are using other systems, this extracellular DNA pops up quite frequently. So we thought this would be a good thing to address. First off, extracellular DNA is not a thing. With pretty much every protocol out there, you're spinning a sample to collect viable cells, and if there is extracellular DNA, you're leaving it in solution and pouring it off. Furthermore, like even if you have that extracellular DNA and you pass it off into your sample tube that will get amplified, you can't spin DNA out of solution with any of the available digests. It's incredibly difficult. And furthermore, if you say you do detect, dead diastaticus DNA, that's still problematic, because at some point you had diastaticus in your brewery, and now your system's, telling you that it's dead, but you had it at some point. So we just kind of wanted to address that and say that, most likely it's an issue with primer stability or sample prep, and that extracellular DNA is not an issue. Our results are completely viable. You collect the cells and leave behind the beer that might have it. On top of that, the yeast in solution eats dead DNA. That's what yeast nutrient is. It's deceased yeast that all these other yeasts consume. So I know with the industry, this is a hot topic, kind of giving lowered confidence in this technology, but on our system, you will not have that issue, and you'll have full confidence that what you're seeing is a viable spoiler if present.
So we're wrapping up the presentation here in the next few slides. I just wanted to dedicate one slide to kind of just the top 3 things that we've learned throughout this whole process. Of like owning a brewery myself for 4 years now, of working with Ironheart Mobile Canning very closely over the past year and a half to screen their customers' beers. And yeah, we put boots on the ground in a lot of breweries over the years. There's 2 types of breweries, honestly. There's those who have had infections and those who will. No matter how good you are at cleaning tanks, the risk is always there. Honestly, the most common vector of contamination that we've found personally and that our customers have found are contaminated yeast pitches. So having a good, strong QA program that can screen those prior to use, I think, is essential in today's day and age. Other thing we've learned is that when these infections do happen, because they do happen, you want to have as much data at your disposal to make a decision on what to do with that particular batch of beer or that yeast. And the answer is not always dump the beer. So again, having all the data at your disposal to make the right decision is honestly essential. Then in this slide, we just threw up a couple testimonials from a couple of our clients. One is Kelly Murphy from Fatheads Brewery, who's also worked a number of years at a small brewery down the road called Great Lakes. Then the second one is from Jacob at Hinterland. And then at the bottom here, you just see some logos of some of our clients, that have decided to be leaders in quality. A lot of these customers have switched from existing PCR systems that they had in-house. Some are going down the road of qPCR for the first time. I think our split's like, 50-50 almost, of people that have some other solution in-house and switch to us, or people that are getting it for the first time.
Once again, if you're listening in and you're ready to upgrade your lab, we invite you to check out our website. We have a cost calculator there, which is great. You can pretty much estimate how many samples you're running, how many samples you wish you were running, and on our website you'll be able to calculate that out. Also, we offer virtual demos now in the age of COVID, where it will take about an hour and a half, and we can run a sample real time. You can see the entire system and get a lot of great data on it.
Awesome. Well, thank you so much, Frank and Adas, for sharing. If anybody has any other questions or anything that kind of comes to mind afterwards, feel free to just jot down their email and contact info. You can also contact us at Quantabio, and we'd be more than happy to help out. Thank you, everybody, for joining, and hope you all have a wonderful rest of your day.